we're on page 4, the last page of the notes for section 1, and we want to walk through just an example here, number 70 and number 72. I just want you to compare these two. First glance, especially even as you read them out loud, they look really similar, in fact almost the same. The product of 6 and a number increased by 3 is 33. The product of 6 and a number increased by 3 is 33. I said the exact same words in both readings, but if you caught it, I didn't try to be too obvious, but visually and also a little bit in my voice, the difference here is these two commas. Okay, commas matter. Very important in mathematics to really notice what's being communicated. And in this case, the commas set it apart. Set it aside for later. Okay, so we're going to do the other translation first, and then you're going to increase by 3. Let's see what that looks like. So the product of 6 and a number increased by 3 is 33. Here's our equals 33. There's our is. We love that when the is shows up. Product, so we know we're going to be multiplying two things, and here's our lovely of and that highlight what we're multiplying. We're multiplying 6 times a number, that number x. Then we're going to increase it by 3, and that answer is going to equal 30. I'm sorry, I wrote 30. Hopefully I said it right. Equals 33. And of course the increased by means we're going to be adding 3, so plus 3 there. So the final translation of this one is the product of 6 and a number, so 6 times x, then increased by 3 plus 3 is 33. Okay, so there's that translation. Let's look at what it translates to with no commas. The product of 6 and a number increased by 3 is 33. Still have our wonderful is 33, so equals 33. We still have products, so again we're going to be multiplying, and our wonderful of and are going to highlight for us the two things we're multiplying. We're multiplying 6, but we're also multiplying a number increased by 3. This entire string goes together. The commas don't stop you. You've got an entire thing until is, a number increased by 3. And that number is going to be x. X increased by 3. X plus 3. So we're multiplying 6 times x plus 3, that whole thing, and that is 33. So the translation here, 6 times the entire item, x plus 3, parentheses will help denote that. 6 times the entire x plus 3 is 33. Very important, very different. As we get to the point where we have our solving skills, for those of you that already do, you go, well, how are these different? Solve these. See what answer makes this true. Up at this top equation, the answer of 5. 5 substituted in for x will make this true. But that's not the case here. The case for down here is an answer, let me just double check in my head, 6, 18, 15, yeah, 2.5 is what will make this true here. 2.5 for x, very different values. So these parentheses matter because the commas matter, okay? So just want to show you that. Be ready for those to show up. Be observant as you're doing your homework. Oftentimes in the notes, I'll throw in some examples of what the book calls Practice Plus, and I'll also throw in examples of application exercises. We'll do an application at the bottom of this page in the next video. But let's look at the Practice Plus. It's a fun way of saying they use some alliteration here. Both words start with a P, Practice Plus, kind of rolls off the tongue here. But what they're really saying is you've got 2 or more skills that you're going to apply in one problem. So you're going to combine something that we've been working on, or maybe with something previously that we've covered, or 2 current skills, or even more. And in this case, we're going to take our evaluation skills and combine it with what we're working on in this section, this textbook section, section 1 of our translation skills. Okay? So evaluate means that we are going to substitute values for x and y then come up with a number result. What is that whole thing? Equal then. Not solving for x and y, we're just substituting and then evaluating, coming up with what that answer would be then. But over here we need to do some translating. Earlier in the assignment you had to evaluate something very similar, but they gave you your x and your y value just right off the bat. Here they give you your y equals 4, but for x they give you a translation. Value for y is given, but the value for x that we need the values to be able to substitute them in. The value for x is going to require translation. So we're going to bring some translation skills here. So we can't quite do the evaluating yet. We're going to have to do some translation first. X is 2 more than 5 times y. Deep breath. X is 2 more than 5 times y. Okay, I've got an is here that's screaming out at me. That's my equal sign. More than, that's a key word. I'm going to be adding 2 more than, so I'm adding 2 to something. 5 times y. Okay, so I'm multiplying 5 times y. So x is 2 more than 5 times y. So I've got my 5 times y, and then I add 2 more to that. Now you could write it as 2 plus 5y. Order doesn't matter for addition or for multiplication, but just kind of practice that. There's a lot of reasons why. One, kind of the way it's phrased, but also we're going to start getting in the habit of putting all our variables up front and the constants, which is just the numbers, plain old numbers, at the end. Okay, but this still doesn't give us a value yet. However, we do know that y equals 4. So we can take, it doesn't give us a value for x, give us a translation, gives us an expression, an equation, but it doesn't give us a value. So 5 times y plus 2, I'm going to take that value of 4 for y and plug it in right here. And that will give me x equals 5 times 4 is 20 using our order of operations, plus 2, so x is going to be 22. So now I can actually go back to my original problem and evaluate x minus y over 3 because I'm going to be able to do, so now I can evaluate x minus y over 3. Notice I copy the problem so I'm not kind of working long distance. Okay, that's what causes some little errors. You can do all the math right, make one copying error as you move from original problem to your workspace, and all that work and time is down the drain. So I've got an x minus a y over 3. My x I found out to be 22. My y is still the given value of 4, and that equals order of operations on the top. 22 minus 4 is 18. Divided by 3, that reduces to 6. Again, the fraction bar equals to division. Hopefully I didn't go off the screen there. I made it, I think, barely. Push it up a little bit. 18 over 3 equals 6. Okay, so that's an example of the practice plus type problems you'll see, more than one skill. I'll see you at the bottom of page 4 for an application exercise.